Hi everyone, my name is Katie. I'm going to talk to you tonight about Chrome DevTools. So who am I? What have I done? I used to work for NPM. I've also worked for companies like Canonical, who make the Ubuntu operating system. As my wonderful introduction also said, I'm a co-organizer of the Front End North event up in Sheffield. We had our first conference in February of this year, and we had 300 people come along. Before I start, just in case animated images or videos on screens make you feel sick or uncomfortable, a content warning will appear in the bottom right hand side of my slides on the slide before they appear, so keep a watch out for that. So DevTools, at least in browsers, have a relatively short history. They're a relatively new thing. If you cast your mind back to 2001, if you remember what the web development was back then, if you got a JavaScript error, this is what you saw. It was a fairly basic error dialog. It told you the line of the script and the row that it appeared in, and it gave you a very, very cursory idea of what the error was. But it wasn't really very helpful, particularly if you're minifying your scripts back in those days. There wasn't any built-in tools into Internet Explorer to allow you to introspect your or view your scripts. Actually found out that you could connect up Internet Explorer up to Microsoft Visual Studio to debug your scripts. You could actually see them, but this error dialog didn't tell you how to do that at all. How would you know? It's very confusing. It doesn't have the best user experience at all. Things didn't really improve until a Firefox extension came along called Firebug, and Firebug, to this day, amongst some of us, is a hallowed name in web development. It really changed things an awful lot when it arrived. It was wonderful. Firebug allowed you to debug your HTML, your CSS, and your JavaScript in the browser. It was just transformational. DevTools, as we know it, shipped with the very first version of Chrome after it was forked from WebKit and technology that the Safari browser is based on. And DevTools itself is based on the Safari Web Inspector. So a long time ago, they actually looked very similar, and they've diverged since then. Since those days, a dedicated team has been adding features for almost every major version release of Chrome to DevTools, and they've had a decade's worth of work towards that now. So my talk is going to be divided into the major tabs that you'd find in Chrome DevTools when you open it, and each one focuses on a different function of web development. The first one is the Elements tab, and it allows you to debug the HTML and the CSS in your page, allowing you to inspect information, the information structure of your page, the SEO, the content, the very fabric of the page that you're looking at. So when you select an element, the style properties are shown in the styles pane in DevTools, and we can use it to add new properties, like change the font of the page to Comic Sans if we wanted to. So I can change the property to Comic Sans MS, and the heading suddenly becomes a little bit more funkier. You can use the arrow buttons on your keyboard to increase and decrease values, such as increasing the font size. And you can use the scroll function on your trackpad and your mouse as well. This could be useful for fine-tuning the position of things. If something is positioned using pixel quantities, you can use the trackpad to just inch it up or down or left or right. It's very useful. Colors have a little swatch preview next to them, so you can select something, click on the swatch, and that will allow you to change the color using a color picker. Which is nice, so I can change the background to blue if I wanted to. The color picker also lets you know how accessible your colors are. So you can use a sampler to compare your text against different backgrounds. And the line that appears will tell you how much contrast is needed to be WCAG compliant. This is useful for designing accessible websites. So as long as you keep the color contrast above this, as long as you pick colors above this line, you'll know that the color contrast is sufficient enough to be accessible. The hover styles simulate cursor hover events. And this is useful because it's often difficult to be in two places at once when you're debugging something that works when you hover over it, like a hover state. So if you select something such as a hyperlink in your HTML, instead of hovering over it in the main panel and then trying to debug it by moving quickly over with your mouse, you can simulate these hover events using the hover styles. So you don't have to be, your mouse cursor doesn't have to be in two places at once. The classes tool allows you to add or remove new classes. For instance, my party class allows me to add this funky little thing that rotates and changes the color of my headings. And you can toggle them on and off as well. When you start typing in the box to add a new class, it also auto-completes them. This can be useful for discovering new classes if you're using a CSS framework such as Tachyons. You might not be able to see me at the moment. I put these intermissions in to have a sip of my drink, but that is what I'm doing. It allows me to break up what I'm saying. You can't see me in person, so that's what I'm doing. Right, the next tab that we're going to look at is the console tab. And this contains the JavaScript console. This is where console.log logs stuff to. So if we log hello world to the console, then we get hello world logged out. This is often maligned as a really simplistic way of debugging, but it's also very powerful. It's very quick. Most of us just use console.log. If we want to really quickly debug something, it shouldn't be mocked. It's very powerful and it's very quick, and we can drop in console.log into our code wherever and just quickly log something out. Of course, sometimes when you console.log something such as an HTML element, you get an HTML preview. So here you can see the H2 tags. Now that might be not really what you want. You might want to instead log out the DOM properties on that node. So if you want to do that, you can instead use console.dir, which logs out the properties of any object. Console.times, that's a timer that can be stopped with console.timeEnd. This is excellent for really quick benchmarking of the performance of your code. For instance, you can start the timer before a function call and end it. Devtools has more sophisticated tools available for you to profiling, which we're going to cover later, but that is a really, really quick way to do that if you want to. Console.memory tells you how much memory your page is using. Now, you might note that this is a property and not a function. This means that you can access this information even if Devtools isn't open, which means that you can put some code in your script to access this if you want to automate this. So if you want to build this into a development version of your application, you want to automate some gathering of performance statistics, then you can. You don't have to have Chrome DevTools open in order to access those. Console.trace logs a stack trace of your script. So if we have functions called 1, 2, and 3, where function 1 calls function 2, which calls function 3, the stack trace shows which function calls are currently in progress and which order they were called in. So you can pull the thread that led up to that point in your script. That can be useful for figuring out what the consequences were for that led up to that point in your script when you're debugging something. Console.count logs an incrementing counter every time it's used. This is useful for finding out how many times a function was called, or how many times a React component has re-rendered. Pinned expressions allow you to watch code as live as it updates. So if we have two buttons which change a variable to duck season and rabbit season, we can see that updating in real time. And as long as that variable is in scope at that point, then you'll be able to see the value of that variable. We can put all sorts of different codes in there. We can call a function if we want to as well. So if you have some important variables that you want to keep an eye on, you can pop it in the watched function, the pinned expressions. Next tab we're going to talk about is the Sources tab. The Sources tab allows you to see the files that are included on your page. This includes style sheets and JavaScript and images, and its secret power really is in debugging your JavaScript code. So here you can find files in the Sources tab by hitting Command or Control and P. And you can type in letters of the file name and Chrome will auto-complete it. So if we're looking for a script called counter.js, we can start typing COU and it will find it. Breakpoints are one of the Sources tab's superpowers. To show you how they work, I've got a script which starts a counter and it adds a number to my slides that counts up in seconds. So let's say we want to see how this script works. We can create a breakpoint by clicking on a line number in the script. Let's zoom in to see how straightforward that is. So if we want to create a breakpoint every time the counter is incremented, we can just click on the line number that's next to it. If we start the timer and then create a breakpoint, the next time that Chrome runs that line of code, it will pause the script. And while our script is paused, we can mouse over those variables. And when we do that, Chrome tells us the value of those variables. And we can get a glimpse into even the most complex, hard to debug scripts. The call stack gives us the same information that console.trace does, showing us the function calls that are currently in progress. And when we click on these functions, we can walk back through time in our script, and we can see all the variables that are in scope at that point as well. The scope pane lists every variable that is currently in scope. And this is not just debugging one or two values using console.log. This is every single variable that's accessible to that line where it's used in your script. So we can see everything that is in scope. The Sources tab's second superpower are the execution controls. These allow us to advance the execution of our scripts in individual increments. So if we've paused our script, we can use these controls to selectively start it back up again. This allows us to walk through our script step by step, line by line. The first one, the resume script button, resumes the execution until the next breakpoint. So when we resume, we can see the counter incrementing every time. For the next control, I have a slightly different example. This one prints out verses of the song 99 Green Bottles of Beer on the Wall and adds them to my slides. The next control is called the step over control. And this resumes your script and pauses it again on the very next line. I found the name of this somewhat confusing. It's called step over because the debugger steps over any function calls that are called on that same line. Chrome still runs those functions, but the debugger will gloss over it and just pause it on the next line of the same file. So the next control is called the step into control. Whereas step over steps over function calls, step into does the opposite, and it pauses the debug on the first line of the next function to be called. So if the next line here is called print verse, the debugger pauses on the first line of that function. Another great control is called the pause on exception control. This pauses the script just before an error occurs, so you can see what consequences led up to them. And you can do things such as inspecting the state of various variables. This function is called isn't defined. This object is called isn't defined, and predictably enough, I've not got a variable defined called isn't defined. So we get an error saying isn't defined is not defined, but that error hasn't technically happened yet in our script. The pause on exception control has halted it before that error occurred. So we can do things like experiment with the state of our script to try and fix things, and also to see what might have led up to this point. The network tab shows you all of the requests that your page is making, all the requests coming to or going out of your laptop. So files, HTML, CSS, JavaScript, Ajax, WebSockets, the whole lot. Any communication that is made from your browser to anything else will be logged in this tab. So the network tab records all the requests made over a certain time frame, and we can control what the time frame is. We're going to use this to debug the NPM website, all the things it loads. Has a lot of features, for instance, for throttling network activity and to record screenshots, which I'm going to show you now. So to simulate a 3G connection, which is a more or less average connection out in a given town in the UK, we're going to open the throttling menu and we're going to select fast 3G. And that will simulate a slower connection than, say, over Wi-Fi or 4G. That's useful for testing our phones where they might be used. Of course, it's not a realistic simulation. It's always well worth testing your websites on real devices, but this is really good just when you want to simulate something. Next, we're going to enable the screenshots function by clicking on this icon that looks like a camera. This is going to take screenshots of our website as it loads over time, so we can benchmark the point that our site becomes usable. So when I reload the page, the network tab automatically starts recording. It records the URL, the response code, the size and time taken for each request. You can click on the screenshots to pinpoint the instant that content becomes usable, and you can use this to optimize the page's critical rendering path by adjusting the order in which the browser loads content. And you can do this to offer meaningful content to your users sooner. Lots of studies have shown that the sooner a website becomes usable, the less likely someone is to go away and try and use a different website, perhaps your competition. So it's always worth using these tools to try and make your website work a little better, to make it work sooner for people. The waterfall is a diagram of the content that's loaded, and we can see it growing as our content downloads. It starts with the document at the top, your HTML document, and then trickles down through other requests that your page is making, such as to CSS style sheets and images. And we can use it to pinpoint important requests, such as web fonts, that are being blocked by less important things. You can click on each bar in the waterfall to get a detailed report, and it tells you figures such as the time a request was spent queuing by the web server, the time it was waiting for a response, or the time to first byte metric, and the time it took to actually download content. It also tells you when the request started, and you can use it in conjunction with the screenshots to pinpoint requests that are being blocked by less important things. This also can be used to pinpoint network issues that might be affecting your web server as well. At the bottom of the network tab, it gives you some performance benchmarks. The number of requests and the total content downloaded is shown. And when you filter requests by a file type, so when you filter just by JavaScript or just by images, these benchmarks update as you filter. This could be helpful for pinpointing bloated content such as unoptimized images or unminified JavaScript. The DOM content loaded event is when the document is loaded and parsed. It's visualized in the waterfall by the blue line. The closer this line is to the left, the better your site is performing. The load event, which is symbolized by the red line, is when all the assets have loaded. So all the images, all the star sheets, all the fonts. This helps you prioritize content. Important CSS and web fonts should perhaps be further away from this line, more towards the left, and illustrative images which don't add a lot of meaning to your website, that are just used to help illustrate something, can be further towards the right, towards this line. So there's a lot of things that I couldn't squeeze into this talk that I don't have time to tackle today. So what I've done is I've created a pick and mix of all the other features that I wanted to talk about, just in short. The first thing that I wanted to talk about is one of my favorite features. It's called the performance monitor. It allows you to monitor the performance and speed of your website in real time as you're using it. So I've got a really, really bad slide that is, every time I click this button, it adds tons of rubbish to my slides. It's a really, really bad slide, this. And we can use the performance monitor to see its effect on the performance in real time every time I push that button. So I'm going to zoom in now on the performance monitor so we can see when I click the button. Every time I click the button, we can see the spikes in CPU usage, and we can see the heap size, the amount of memory that's being used by the browser increasing. This is a seriously, seriously bad script. Every time I click the button, it's adding 100 megabytes to the heap size. So we can use this to study the effects of us using our apps, and it will tell us in real time. For a long time, we only had these kinds of developer tools for things like debugging operating systems. It is frankly amazing that we have this in our browser Devtools. The command menu also gives you shortcuts to features, and you can use it to discover a lot of things that you didn't know about. So you can open it, start typing, and it will auto-complete stuff with things that you could use. You can open it by hitting Shift, Command, or Control and P. When you start typing, it will find things for you. So for instance, you can use it to open the FPS meter, which gives you a real-time frame rate of the animation, how fast your page is animating. For fans of dark themes in their editors, Devtools has a dark theme as well. You can enable it by using the command menu and typing dark theme, and then you get a dark theme that you might find in your code editors. If you're writing a JavaScript-heavy web application, Devtools has a JavaScript profiler to help you identify really, really slow functions. In this demo, I have two buttons which call different functions. Both of them take a really long time to run, but the long function does twice as much work as the short function. So we would expect it to take twice as long to run as the short one. So let's go ahead and hit record, and we're going to click both both these buttons, which is going to run both of those functions, and we can see the results. We can see that both the long function and the short function has shot up to the top of these results. They're both taking ages to run. And as we expected, the short function takes half the amount of time as the long function to run. When profiling, we can use the profiler to spot performance bottlenecks in our application and find functions that are doing a lot of more work than they need to and taking a long time to run. When we open the sources tab after we've done a profile, Devtools will show us the results next to the code in our functions. We can use this as a kind of heat map to see functions that are running hot, functions that are just running really, really slow. And that allows us to really easily spot bottlenecks in our code. Devtools is also not limited to just your front-end code. You can use it to debug and profile your Node.js code on the back end as well. When starting your script in the terminal, you can use the inspect break switch in the command line, and this will start a node. This will start the node in debug mode and pause it on the first line of your script. In Devtools, the Node.js logo in Devtools will light up so that we can click on it. And when we click on it, a new window opens showing our back-end code. For instance, in the scope pane, you can see the exports variable, which is a hallmark of running a Node.js script. Last but not least, Devtools ships with a powerful suite of auditing tools called Lighthouse. When we open the audits tab, we can see the things that we can measure. So we can measure our website for performance, PWA compliance, accessibility, and SEO. So you can click on audits to see the results, run audits, and it will generate things, simulate lots of different network conditions for our website, crunch through the performance, and it will show us the results. So we can see here the performance of my website is fairly strong, but the accessibility leaves a little bit to be desired, and it could be a much, well, it's not a progressive web app, so it's not giving me particularly good results for that. But it's very helpful. It gives you a lot of insight into how good your website is. Lastly, what about Firefox? Firefox also has a great suite of developer tools and a team working very hard on them, doing some great work. All of the features on this slide that I've talked about today have equivalents in Firefox, so it's well worth checking them out as well. So how would I sum up Devtools to you? Well, this is Gene Kranz. He's one of my heroes. He was the flight director for the Apollo 13 and Apollo 11 space missions. And shortly after the Apollo 13 accident occurred, he pulled his team together and tried to put them in the right mindset for tackling an emergency by saying, okay, people, let's work the problem. Let's not make things worse by guessing. That's how I feel about my career as a developer before I started getting a better idea of how to use developer tools. I felt like I would just change things in my script at random to experiment to see if I could fix a bug. And by learning how to use developer tools, by learning how to use Firebug, by learning how to use Chrome Devtools, I could actually see what was really happening in my code. This was transformational for my mindset as an engineer because I wasn't changing things and debugging things by guessing anymore. I was actually able to see the effect that my code was having on my application. I think it made me a better engineer, and I think it can make everyone a better engineer by having a greater understanding, a greater appreciation of developer tools. So I highly recommend that you open the Devtools tab in your browser and have a look at your scripts and give it a go. Thank you very much.
That was an amazing talk, Katie. Thank you.
Welcome.
So out of all those features of the Devtools, what is your favorite?
My favorite is, I'm just going to sort out my screen. I'm not showing my screen anymore. I'm going to make sure that I open the QA. My favorite feature is the performance monitor, because it just gives you that wonderful graph which shows you like your CPU usage spiking. We've never had anything like that before. That is absolutely amazing. I kind of like the console as well, because it allows you to just like, it allows you to experiment by typing in JavaScript. There's also a really nice feature in the console, I think it's in the sources tab, that allows you to save code snippets. So if there's pieces of code that you use often, such as if you've written a little script to automate a sign up form on your website, then you can save that to the snippets tab inside the sources panel, and it will save that code there for after you've closed your browser, even restarted your computer for the next day. So you can save your snippets there for doing things like testing, automating things, all sorts of things. You can put things in there. Also really useful for doing things you might do in CodePen or JSBin. You can save your code there and have it all in private in your browser.
Cool. We've got a question from Maria. Is Lighthouse as powerful as the native Devtools techniques you've spoken about?
Native Devtools. I'm assuming that you mean the native Devtools inside the operating system. I don't actually know the answer to this question. I wonder if we can have a chat in chat later on, because I'm not sure really how to answer that.
Okay.
Are there any comprehensive online resources that you can recommend to learn how to use DevTools? They have really, really good documentation on the Google Chrome website, which is really good. There used to be sort of like a video podcast that was created by Adi Osmani, which I think is still available somewhere. That dips into how to debug, how to use Chrome DevTools to debug your code. It's really, really old now, but a lot of it might still be relevant today, particularly for like seeing how to run how to take some metrics, how to measure your code, make some changes, and then to measure it again. That was really good, but again, it's an old video podcast now, so it might not be that relevant. I think also some of the Google DevRel team have a podcast. There's the HTTP 201, I think. I can't remember what it's called. I'm going to have a look at my podcast now. It's from Jake and Sermon, the Google DevRel team, which is really, really good podcast. HTTP 203. They have a good podcast. They often dip into DevTools and things, and you can find out lots of really interesting things. There is also the release notes. The release notes help you learn about new features that are being released. It's always worth opening up Chrome DevTools every now and again to see a little tab that tells you about new features. So it will announce new things that are being released for DevTools every time you open it and there's been an update. Do I have a blog post on this topic? I do not, I'm afraid. So I'm sorry.